In this video, we are going to begin discussing continuous data. In the previous videos, we have discussed qualitative data and their graphs. Those were the bar graphs, the Paretos, the pie charts. We've also discussed quantitative data that was discrete. We looked at the frequency distribution as well as the histograms for discrete data. We now want to turn our attention to continuous data. Remember that continuous data means that it can be one item, the next item, or anything in between. A lot of times when we're looking at continuous data, we have these intervals that we are looking at. The intervals that are created are called classes. These different classes, we put a group or a person or an income into a different group. Think about when you applied for college or when you applied for a job. Many times on the application, it does not say, "What is your age?" It says, "What is your age range?" You're basically putting yourself into a class, a category at that point. These classes help us identify how we look at the data. A couple of things to note about the classes. Here we have the age of people, and notice its number in thousands, that currently work disabled, who are currently working disabled. And you'll notice the first age group is 25 to 34. The second one is 35 to 44, 45 to 54, 55 to 64. One thing to note is notice there is no gap in here. This class ends at 34, this one begins at 35. This one ends at 44, this one begins at 45. So there's no gap in between each of our classes. These values here are what we call lower class limits. This signifies these are the lowest possible values that can be in that class. The values up here, what do you expect those to be? Well, those are called the upper class limits. The upper class limits are those that give us a maximum value that can be in that class. So you'll notice that this is the oldest person, 34, that could be put into this particular class. The difference between the classes here is called the class width. The class width is calculated one of two ways. The first way is if we already know the classes, such as this data. We already know where each class starts and where each class ends. So the class width in this particular case is going to be equal to the lower limit minus previous lower limit. Whenever we talk about the lower limits, recall they're these values. They're on the left-hand side. For example, if I look at this particular chart and I want to find the class width, I pick a lower limit, let's just say 35, and I subtract the previous lower limit of 25. Therefore, my class width is 10. When we look at these, you will notice that the class width is consistent the entire time. Add 10. There's a difference of 10. there's a difference of 10. If we started a new one, notice this one ends at 64, the next one begins at 65. Another thing to note is the lower limits increased by 10. The upper limits also increased by 10. This is one way of calculating the class width. This is if we're already given our frequency distribution. We're already given our classes. Sometimes, most of the time, we are given just the raw data. When we're given the raw data, we have to actually calculate the class limit. So what we need to do is we need to first choose the lower class limit for the first class. Very honestly, most of the time, this is just our smallest data value. That is usually our lowest limit. Now sometimes if our smallest value is 21, we'll back our lower limit up to 20 to make it a nice even number. That is perfectly valid. That is our first step, is to determine our lower class limit of our first particular class. Then we need to look at the class width. You want to identify how many classes you want. We usually pick between 5 and 20. A lot of it depends on how widespread your data is. If you have values from 7 to 1,000, you may want 20 classes. It depends also on what you're discussing. Most of our data doesn't have a huge range, so a lot of times we'll pick 5, 6, or 7 classes. Maybe 9 classes, depending upon what we are looking at again. Class width is computed by taking the largest data value of our raw data, so of the numbers that we have, we look for the largest one, and we subtract the smallest one from it. And here's a hint, this calculation in the numerator is called our range. It is our highest value minus our lowest value. Then we divide it by the number of classes. Now I want to make a note here. We always, whenever we're discussing class width, round up to the next whole number. This is very important because when we are discussing class widths and class limits, we really need to pay attention to being consistent. When we get and calculate a class width, we always want to round up. The reason being is the fact that if we round down, use our normal rounding rules, whatever it happens to be, the calculation is telling me that I need 4.3 numbers in each class. Well, if I round down to 4, normal rounding rules, I'm not going to have that extra little 0.3, that 3/10. Therefore, I'm actually going to end up short a class because I don't have enough space for all my data values. If I round up, then I will have enough space. What this says, a class width of 4.3, is I need to have at least 4.3 data values in each class. So if I round down to 4, I'm not going to have enough. Think about whenever you are talking to a cashier or something along those lines, and you look at it and say, okay, I owe you $4.30. Can you give them $4? Well, that's a rounding down. That's a normal rounding if you're rounding by dollars if you don't have any change. If you only give them $4, they're going to look at you as if you have 10 heads or something. they're going to ask for more money. If you give them $5, yes, you have given them too much, but you have covered yourself. You no longer owe anybody. This is the same thing with class width. I need to make sure that I have that extra part. A lot of times we call that a buffer room. And so we usually have a little bit of buffer there. Here is some data. It says the following data represent the time between eruptions in seconds for a random sample of 45 eruptions of the Old Faithful Geyser, which is not in California. It's up in Yellowstone. This data, they have gone through and measured the time between eruptions for Old Faithful Geyser 45 different times in seconds. The first interval was 728 seconds. And they've done this measurement to get a nice distribution. We want to calculate the class width using 7 classes. Whenever I look at class width, my 7 goes on the denominator. That's how many classes I want. My next step is to go through my data, and it may be easier for you to put it in order from least to greatest. You can always use Excel program or another type of program to help you with that. But we need to go through here and look and see what is our smallest value. I'm seeing some 600s. So let's see here. If I underline all of my 600s and I look at them, 672 is my smallest. 672. My largest value, if I look down through here, I'm seeing some 730s. Do I see anything larger than a 730? My 738 is actually my largest value. Be sure to do order of operations when you're doing this calculation. Be careful if you're entering it into the calculator. If you enter it into the calculator, make sure that you put parentheses around the numerator and parentheses around the denominator. Otherwise, you will get a much larger number than you need. I'm going to do it step at a time. So I'm going to take 738 minus 672. I get 66. Then I'm going to divide 66 by 7. I get 9.4. Recall our note, we always round up. Normal rounding rules would tell me to round this down to 9. But again, I do not have enough if I round it down. Therefore, I round it up and I use 10 as my class width. We have just calculated class width. We now want to construct a frequency and relative frequency distribution, just as we did for qualitative data and our discrete quantitative data. When we look at this, we need to set up our classes. So I know that there's going to be a lower value and an upper value. Notice it says begin the lowest class at 670. Now that's not my lowest number, but it's a nice round number. And so we're going to start with 670. My class width is 10. So what I'm going to do is I'm going to add 10 down. I'm not going to add it across. I'm going to add it down. This will give me my lower class limits. So I get 680, 690, 700, 710, 720, 730. If this class begins at 680, what does this class have to end at? It has to end at 679, and I'm going to go ahead and add that last decimal because we could measure half seconds, milliseconds, that type thing. Adding that extra 0.9 just signifies there is nothing in between these two. They butt right up next to each other. If this class begins at 690, this class is going to end at 689.9. Recall what I said about the class width and the upper class limits? If I add 10 to the lower class limits, I can also add 10 to the upper class limits and receive those values. And 739.9. So we have created our different classes here. Once we create our classes, we need to organize our data. We need to go through there and put 728 in its proper class, 730 in its proper class, and so forth. I would highly recommend that you pause the video and put the values that you find here and then check back. Once I have tallied these up, I found that I received two numbers between 670 and 679.9. There were 0 numbers between 680 and 689.9. I cannot eliminate that class though, because these are valid values for the eruption times. Therefore, I still have to include it in my class. I just have a frequency of 0. Remember, these must butt up next to each other. I cannot eliminate anything. I received 7 values from 690 to 699, 9 values for the next 2 classes, 11 values for 720 to 729, and 7 values for 730 to 739. Again, check your numbers against mine and see. Hopefully, if we did this correctly, recall it told us that there were 45 eruption times. If I add these numbers up, which I need to, and get in, if we did that correctly, we should get 45. To calculate relative frequency, recall that it is your frequency divided by your total number. I'm going to take 2 and divide by 45. And I'm going to round to 3 decimal places. So I get 0.044. This one's nice and easy. That's a 0. 0 divided by anything is 0. Then 7 divided by 45 is 0.156. Remember rounding rules. 9 divided by 45 is a very nice 2/10. 11 divided by 45 is going to be 0.244. And 7 again was 0.156. You can add these up. They should add up to approximately 1. Now, if you're off by 1/1000th of a decimal place or something along those lines, that's fine. If you're off by, say, 2/10, we're in trouble. We've miscalculated somewhere. Once we create the frequency distribution, which is what this is, the next thing to do is do our graph. Our relative frequency or our frequency histogram. We draw the histogram very similar to what we did previously. I want to note a few things when I draw this. When I draw this, I'm going to use the lower class limits. You'll notice that I don't put the upper class limits up here at all. All I'm doing is using these lower class limits. And the reason for that is because we know that they butt up next to each other. Now notice my last lower class limit is 730. That's where this one starts. This one ends at 739.9. But again, I want to use those lower class limits, so I'm actually going to use 740. These are times between eruptions. And so I want to make sure that I label this properly. And the time was measured in seconds. Again, notice these are lower class limits. I'm going to put my frequency along the vertical axis. And I need to go everywhere from 0 up to 11. Because 11 was my tallest. And I'm just going to put a number beside every other one, but it still signifies 1, 2, 3, 4, and so forth. When I'm drawing continuous data, I do not draw a box over the number. Remember that my first class began at 670. It began here. I'm going to start my box there, and I had 2 values in that one. I'm going to end my box at the next number. So what this signifies is that there are 2 values between 670 and 680. They're not 2 values at 670, they're 2 values between those 2 numbers. Now between 680 and 690, there were none, so I leave it flat. Between 690 and 700, there were 7 of them. So I'm going to draw my bar up here, and I'm going to end it here. Between 700 and 710, there were 9, so I'm going to extend my bar up, and then you'll notice that I drop it back down to the middle of 710. This one's kind of nice because the next category had 9, so it's the same height. Then I extend it up to 11. And again, notice I'm dropping my bar to the very center of these numbers because that is where they're ending, or that is where they're beginning, okay? My last class had 7 in it, so I'm going to take this here. Again, a few things to note. My bars touch where necessary. Yes, there is a gap right here, but that's because there's basically a bar right here at 0. And if you want to darken that line, that is fine as well. I have labeled both of my axes accordingly. Notice I didn't just put lower class limit. I put a descriptive label there. So be specific. I'd like for you to try graphing some of the histograms, and then let me know if you have any questions.